Okay, so we're discussing the theorems in circles, and this is one of the theorem under cyclic quadrilaterals. Okay, so theorem is this one: cyclic quadrilateral and whose sum of the opposite angles is 180 degrees. That's all. Okay, sum of the opposite angles in a cyclic quadrilateral is 180 degrees. So what is this? ABCD is a cyclic quadrilateral. Now what we need to prove? Sum of the opposite angles in a cyclic quadrilateral is 180 degrees. So these two sum is 180 degrees and these two sum is 180 degrees. That is what we need to prove it. Okay. So actually the intention is we need to prove this theorem. I already proved in a textbook manner. So here we are going to prove with the different view, okay, in a different perspective. Okay, so that is what I am going to try it. Okay, so the textbook, it was given with the arc and a center, and this is actually different. Okay, we are going to do it different. So I just wanted to explain how we are going to prove it. Okay, so first let me write a given. So what is given? A cyclic quadrilateral is already given, and we need to prove whose opposite angle sum is 180. If two angle sum is 180 degrees, then what do you call that pair? That pair is called as what? Supplementary angles. Okay. So what do you mean by this? A and C are pair which are supplementary. B and D are pair which are supplementary. Only when a quadrilateral is cyclic quadrilateral. Okay. So in a cyclic quadrilateral, the pair of opposite angles sum is 180 degrees. The pair of opposite angles sum is 180 degrees are supplementary. So this is what we are trying to explain here. Just have a concentration. First, ABCD is a quadrilateral. Is it simply quadrilateral? All the vertices of a quadrilateral are lying on a circle. So therefore it is a cyclic quadrilateral. Okay. Now what exactly we need to prove? What required to prove? We need to prove angle A plus angle C is 180 degrees. Why? Why only angle A and C? Because A and C are opposite, or we can even take B and D whose sum is 180 degrees. So either of that can prove it. Why? Is it enough to prove the one and leave the remaining? Yes, absolutely. Why? Because if I prove angle A plus angle C sum is 180 degrees, angle B and angle D ought to be 180 degrees, because there is no other option, because all the angles in a quadrilateral is 360 degrees. So these two are anyway making 180 and the other two have to make the 180. So there is no other option. So if you prove either of this case is going to be enough to call the statement true, right? So now we'll take up this and we'll try to do this. Okay, so let's try that. So I just wanted to explain how we are going to prove it. So when generally if I start every step one by one, okay, you may not understand. So what I am going to do is, what I am going to do, okay, if I explain the broad view what I am going to do, then that can be easy to understand. Because for example, you started your journey, and if you know the destination, then you can feel the destination. So here also you can feel little better, and you can feel you are comfortable in understanding the theorem in the easiest way if I explain the root map of it. So how I am going to prove this is, I am going to take the segments. Okay, so first I would like to take this AB segment. So this is what we call it as segment, the region occupied by a chord and its associated arc, an arc and a chord, the area which is called as segment. So first I would like to take AB segment. Next I would like to take BC segment, and later I would like to take CD segment, and then I would like to take DA segments. Okay, but segments alone does not help us to prove it. Okay, so we need to take the angles subtended on this same segment. Okay, so now if you observe here AB segment, was it making the angles anywhere in ABCD? Okay, see, AB is not making the angle with D. AB is not making the angle with C. But we need to prove with the help of we need to prove that with the help of subtended angles. So to do that, what I am going to do is, okay, so we need to join this A and C. Okay, so what exactly I am going to do? I am going to join this A and C. Why? Because AB is a segment whose ends are making the angle at C. And what is the other view? I mean, what is the other chance that AB can make on ABCD? AB can also make an angle at D, and the angles in the same segments are equal. Okay, the angles in the same segments are equal. What do you mean by that? Okay, so this is the same segment which is making it the angle at C, the same segment which is also making the angle at D. So these two are going to be same. For example, if the angle is making here X, so here also it is going to make X. Okay, so this is how I would like to start it. Okay, so let me explain. I am starting. I just wanted to explain the plan, but I forgot. Right. So AB is making the angles at C and D. So to make the angle, I am joining A and C, and to make the angle at D, I am joining B and D. And these two angles are going to be same because those are the angles in the same segment. So after that, I would like to take another segment. What is the remaining other segment? We have four segments here. BC segment. What is this BC? Okay, BC, if you observe BC is also making the angle at D at this location. BC is also making the angle at A, and this is the same segment. The angles in the same segments are equal, so therefore this angle is equals to this angle, and the angle over here is equals to the angle over here, which two are equal. Okay, right. Next, later I would like to consider CD segment, and on CD segment, okay, CD is the same segment which is making the angle at B. The same CD segment is also making the angle at A, and these two are also going to be same. So if I take this angle, if I take CD at B is Z, CD at A is also going to be Z, but we need to take it this side because CD angle with A we have to take, not Y. CD is not making with Y, right? Okay, not this angle, right? So now lastly I would like to consider another segment which is DA segment. So what is DA segment? This is the DA segment. So this is the DA segment. Now DA is making the angles at C at this side. DA is also making the angle at this side down. Okay, DA is making the angle at C at top. DA is also making the angle at B at downside. Okay, so those two are going to be same and which are equal. Okay, so I would like to take this angle as, okay, x, y, z, all the variables are done. Now I would like to take this as P. So if this is P, then this is also going to be P. Once again, DA is making the angle at C, DA is also making the angle at B. So those two are equal. Now, so how we are going to do it? Okay, we are going to do with the help of sum of the angles in a quadrilateral is 360 degrees. That's the easiest way we can understand this theorem. Okay, so construction is nothing, just joining. Okay, join A, C, join B and D. That's all it is. I don't think that need to be called under construction. Okay, so right, let's take the proof now. And how are we going to prove? We are going to prove with the help of sum of the angles in a quadrilateral is 360 degrees. So angle A plus angle B plus angle C plus angle D is equals to 360 degrees. Right? Okay. So this is the I mean theorem, we are going to take the help to prove this. Now, what is angle A? See, in angle A we have z plus y. In angle B we have p plus z. In angle C we have x plus p. In angle D we have x plus y. So, I'm about to explain the plan, but in the process of doing it, I just lost it. That's okay. Right, angle A. Okay, if you observe angle A, what are the angles involved in angle A? Z plus y. What are the angles involved in B? P plus Z. What are the angles involved in C? P plus X. And this is X plus Y. So therefore, angle A is equals to what? That is Z plus Y plus angle B is P plus Z. Angle C, P plus X or X plus P. Angle D, X plus Y. It's equals to 360 degrees. Right. Now, here if you observe, we have x and x, 2x, y and y, 2y, z and z, 2z, and p and p, we have 2p. So, x plus x, 2x, y plus y, 2y, z plus z, 2z, p plus p, 2p. So, which is going to be something like this, 2x plus 2y plus 2z plus 2p is equals to 360 degrees. And you can take 2 common. If you take 2 common, you'll get something like x plus y plus z plus 360 degrees. So it's multiplying. Okay, this can be treated as one single term, so you can cancel out from here. Okay, or else you can, if you don't understand, you can transfer 2 to the other side. It's going to become 360 by 2, which is 180 degrees. So what you got finally, you got with x plus y plus z plus p is equals to 180 degrees. And this is a proof, I can say. Why? Because see, what exactly we need to prove? We need to prove angle A plus angle C is 180 degrees. See, if you look at this one, I just have chosen an algebraic way to prove it. Okay, because some of the geometrical concept, I mean, to understand some geometrical concepts, it's better to take, it is better to include the geometry here, x and y as kind of a variables. Okay, because if you just explain everything with a, b, c and all, okay, it's going to create a lot of confusion and a mess. So to avoid that, I have taken this algebraic way, and many people are better comfortable this algebraic understanding. Okay, so write x plus y plus z plus p is this one. Now what exactly we need to prove? Angle A and angle C. What do you mean by angle A and angle C? Z plus y. So do we have z plus y? This is nothing but angle A. And what do you mean by other one? X plus p. X plus p means what? That is C. So angle A plus angle C is equals to what? 180 degrees. That is nothing but sum of the opposite angles is 180 degrees. In the same statement, we can show angle B plus angle D is also angle B plus angle D also. What is that? Angle B is nothing but what? P plus Z. So now we need to consider P and Z. This gives angle B value. And what is x plus y? That gives the angle D value. So angle D plus B, which you can also write it as angle B plus angle D. So this is also going to give in a single statement. So in a single statement, we can prove these two statements, of course. So why I am taking this one? Because I mean, so and in understanding this theorem, okay, you are not using much concept. Just two theorems we are using. One is sum of the angles in a quadrilateral is 360 degrees, and the other one is, okay, we are using the angles in the same segments are equal. So this is just understanding this theorem in other view. Okay, so the only intention to bring this theorem is, okay, there are various ways and different ways. When you understand one more interesting or one more method in understanding a same theorem, if you understand a same theorem in a different method, which gives much more confidence, and along with the confidence you will also feel, okay, you learn something better than something, okay, better than uh, you as usual. So that is a point which I just wanted to make it clear. So this is a theorem and this is a proof. Okay, right? See, 1 is enough to prove, but we have proved here 2 in a very easiest manner. I hope you understood, and it gives some different clarity than usual. So that's all. Thank you for listening to me.